This is topic 3.3, differentiating inverse functions. Let's first recall that a function's inverse is found by swapping the input and the output values. Basically, they interchange the domain and the range. They're x and y values. Okay? Some confusing notation. X with this negative 1 as its exponent, that means 1 over x. That's a reciprocal. But this notation with this negative 1 here after f, after our function notation, means inverse of f. Okay? So this is the function whose domain right here is actually the range of that original function f of x. Okay? 3 ways to say the same thing. Basically, these 3 ways, these 3 things say the same thing. G of x is the inverse of f of x. G of x equals f inverse of x. And f composed with g of x equals x, and g composed with f of x equals x. Now, I'm sure you had this in pre-cal. To show that 2 functions are inverses of each other, if you compose them, each f with g and then g with f, both of those will equal x. If that takes place, then f and g are inverses of each other. Okay? So let's just jump right to our derivative. This is something you're going to have to memorize. It's just, there's no way around it. Okay? So there's some things in this class that we just have to memorize, and this is what it looks like. 1 over f prime of f inverse of x. And it's just something you're going to have to know, okay? So this is the derivative of f inverse of x. And every problem you work, you should probably write this down, okay? So let's begin with our first example and see if this makes some sense, okay? Okay. So we're given a table of values. Keep in mind that we have f of x and we have f prime of x in our table. And they give us g of x equals f inverse of x. And they'd like us to find here in number 1, g prime of 1. So g prime of x is the derivative of f inverse of x, okay? So really what they want us to find in number 1 is the derivative with respect to x of f inverse of 1. Because this notation says for this, and here is f inverse of 1. In fact, just to keep it clear, that maybe you don't confuse it with something else, you could use this notation. Sometimes it's nice to not have that derivative notation there. Okay, let's see what this means. We're going to write our formula from up above. It's 1 over, and we're going to have f prime of f inverse of 1. Okay, this 1, right, is where that was, okay? So we have to find out what these tables are. Remember, we're going to work on the inside first, so I'm going to write f prime down. And we need to find what f inverse of 1 is. Now, some of you may say, oh, I'm going to go to 1 and it's going to be 3. That's not what we're looking for. What I suggest is writing down a function value. F of 1 is 3, and see if that gives it to you. But f inverse of 3 is 1. So this is not what we're looking for. We need f inverse of 1. So we're actually looking for a y value that's 1. Do you see it right here? A y value that's 1. So that's not the point that we need. Let's try another one. How about this? F where the y value is 1, f of 2 is 1. So f inverse of 1 is 2. And guess what? That's what we need right there. And I got that from the table right here. I looked for that y value that was equal to 1. Okay? So let's go ahead and put that in. F inverse of 1 is 2. Well, now it becomes kind of nice because it's 1 over, and we go to the table, and f prime of 2 is a negative 2. When x is 2, f prime of 2 is negative 2, and you guessed it, this is negative 1/2. Okay, let's look at this next problem. Write an equation for the line tangent to f inverse at x equal to 1. Well, the second we see that in this class, we write a point and we write a slope. And that always allows us to write the equation of a line. Okay? So when we see x is equal to 1, that is definitely 1. But now we need to have this point on f inverse. Okay? So f inverse of 1, and we found that over here, that f inverse of 1 is equal to 2. So 2 is our y value. Now keep in mind, this is the x value. I'm even going to write that down. This is the x value for f inverse. So it's the y value for f. Okay? So that can be some kind of confusing. So really all we need is the slope, but we found it over here. From number 1, the slope is negative 1/2. That's the derivative of f inverse of 1. Okay? So that's negative 1/2. So now we're home free. We have everything that we need to write the equation of a line. So we have y minus the y value equals the slope x minus the x value. Okay, so that turned out nice. This next problem has a lot of information in it, and it can get to a point where you can't find what you need. But I think I would just maybe look when you need it, or you can highlight it when you find it. We'll just take our time with this, okay? Bottom line is we have a differentiable function g, and we're given some values of g, and we're given some values of g prime, and then we're also given that h of x is equal to g inverse of x, and they want h prime of 6. So what does that mean? If they want h prime of 6, they really want the derivative. See, this is the derivative of h. They really want the derivative of g inverse of 6. We're going to go right to our formula. This is super important that we write this formula every time. So it's 1 over g prime of g inverse of 6. I really didn't give enough room here, so I think I'll just write to the right of this, okay? Remember, 1 over, write that outside function down, and we need to find g inverse of 6. So what's really important is we know that g of 3 is equal to 6. That's given. So it must be that g inverse of 6 is equal to 3. Okay, and now we need g prime of 3. So from the table, g prime of 3 is negative 2. And again, we have an answer of -1/2. Not every answer is going to be -1/2. Okay, let's look at number 4. Now, this is probably as difficult as these questions get. Okay, so we need to write a few things out, figure out what they're asking for. We want to find the value. What is the value of G prime of 25? So really, let's write that a little bit nicer. They tell us that G is the inverse of F, okay? I might even write that down. G is F inverse. So now that I am asked for G prime of 25, they're actually asking us for the derivative, with respect to x, of F inverse of 25. Okay, keep in mind that's what G is, F inverse. So G prime would be the derivative of F inverse. Okay, we're ready to write our formula? That's equal to 1 over F prime of F inverse of 25, okay? If you write your formula, it won't be as confusing. And now we need to go find that 1 over, we're going to write F prime on the outside, and now we're going to find out what F inverse of 25 is, and you're probably thinking, oh my gosh, how am I going to find that? Well, if F of x is equal to 3x cubed plus 1, and we need F inverse of 25, F inverse of 25, 25 is the y value of F. So we actually need to go set 25 equal to 3x cubed plus 1. Okay? So when we do that, 25 equals 3x cubed plus 1, 24 equals 3x cubed, 8 equals x cubed, and obviously 8 is 2. So on the graph of F, we have 225. So F inverse of 25 is 2. And 1 over F prime of 2. Now you might be asking, how am I going to find F prime of 2? Well, let's write F prime of x. I kind of wrote a little large here, but I'll change color so it's not confusing. F prime of x. Look up here at our definition of F. And F prime of x is 27x squared. Oops, not 27, 9, sorry. And so F prime of 2 is equal to 9 times 4, and that's 36. So we actually have 1 divided by 36. And that's our answer. I don't know why that turned that color. So that's about as tough as it gets. And that concludes this topic.